Hello everyone, and welcome to my partial fraction decomposition lesson. So today we have a new problem, and our first step, we will separate it into categories. So what that'll look like, we'll have it equal A, B, and C. So we have on our denominator a repeated factor. So it is cubed like this. So basically how we write it into the decomposed part, it has to be in ascending order. So it'll look like this: x plus 2 like this, and then b will be x plus 2 squared, and c will be x plus 2 cubed. So this is our first step. So what we did was kind of separated it into its categories. Right? So now with the next step, what we have to do is we have to get common denominators. So to get common denominators, we have to use the special form of 1, and so basically we have to multiply what each one is missing. So since this is x plus 2 cubed, the rest of the denominators over here need to be x plus 2 cubed. So to get that, we need to multiply by a special form of 1. So this would basically be like this. So it's a big 1, and to get x plus 2 cubed, you need to multiply x plus 2 to here. So since it's 1, it'll be x plus 2 over x plus 2, because that equals 1. So we have to do that for this side too. So to get x plus 2 to x plus 2 cubed, we need to multiply it by x plus 2 squared. So that will be our special form of 1. We will be multiplying here. X plus 2 squared. X plus 2 squared. So that's where we are right now. So this will get us our common denominator of x plus 2 cubed. Since this is x plus 2 cubed, it could stay the same like that. So now we want to write it. I'll write it out. So it's a times x plus 2, because that's our special form of 1. X plus 2 plus b, since it's being multiplied by x plus 2 squared. No, this is being multiplied by x plus 2 squared, and this is being by x plus 2. So it would be times x plus 2 and plus c, because c isn't being multiplied to anything. And this is all over x plus 2 cubed. So now that we have our common denominator, now we have to multiply the a to x plus 2 and squared, and b to x plus 2, and so on. So now we have to multiply. So we don't really have to worry about the denominator for now. So I'll just write out the numerator. So this will look like this. Plus b times x plus 2 plus c. So now we just need to multiply it out. So a times x plus 2 squared, which will look like this. Ax squared, right, plus 4ax plus 4a, and then since we did that, now we have to do this part. It's still the same, so plus bx plus 2b, and then plus c. So here's where we are right now, and after we multiplied everything together, now we kind of sort it out so we can start our foundation for the matrix. So we can think of it as a table. That's how I like to think of it. So it will be organized like this. So we'll have our highest variable power. So for example, it would be x squared right here. So that would be x squared here, and whatever falls underneath it. So if it was x cubed, it would start x cubed, and then it'll go x squared, then x, and then the one without a variable. So this is what it looks like: x squared, x, and then the one without a variable. And then next it would be our other variable, so like up here, ABC. So since we only have ABC, that's what it'll be over here. A, B, C. So this is our table. So it'll look like this. Right? So now we can organize out what we got here, our answer that we multiplied. We organize that into our table here. So I'll do that. So ax squared goes with the a and the x squared. So it will be here, ax squared, and we have our letter a, and it goes under the x column. So it'll be right here for ax, and we have for a. Since there's no x, it'll go right here for a, and that's how all of our a's. So now we have b. Since we don't have bx squared, nothing goes right here. So we have bx, so that falls under here because there's the x. And then we have 2b, there's no x, so it'll just be 2b. Right, and we have c, so c doesn't have cx squared, it's not cx, it's just c by itself, so it's c. So from this table, we can write it out. So how we read this, also before that, we have to put what it equals. So all this equals, we have to refer back to our numerator. So what we read here, see, the same thing, we can still follow it with the x squared. So we just match it up. So negative 2x squared will go under this column. Next is negative 5x. I'm just taking the numerator. Negative 5x. And then minus 1. So how we read this table, it will be going down. So it's read like this. So we read down. So basically a, since it's only, this is only a, it's only x squared, there's no b or c. So what we can conclude, so right now x squared and the x's, those are just like placeholders, so we don't really need to worry about them. So basically a equals negative 2. So we can just get rid of the x squared from both of them. A equals negative 2. So we're going to do the same thing. So we're reading down. So as we read down, right, so it'd be 4a plus b equals negative 5. Right? And then this one, same thing, we're reading down. So 4a plus 2b plus c equals negative 1. So 4a plus 2b plus c equals negative 1. I should have organized that a little better, but it's okay. So this is now our foundation for our matrix, and we're only using the coefficient, so which is basically this for our matrices. So yeah, we don't have to look at the x squared or the x anymore. It's just a placeholder. So now we can start to build our matrix. Okay, so now to put this into a matrix, what we have to do, so just like last time, so since we have a equals 2, that's an easy one. So since a is the only like variable here, we're looking at its coefficient. Since it's just a by itself, it's a coefficient of 1, so it'll be 1. And since there's no b or c, it's zeros, which is really good for converting our matrix later. So this is the first step. So now we look at the other one. 4a plus b, and there's no c. So we're looking at the coefficient. So it'll be 4a, right? These are all a's. 4a plus b. So since it's just b by itself, it's 1. And there's no c, so it's 0. And equals -5. So again, 4a plus 2b this time. And it would be 4. We're looking at the coefficient. That's 2b, be 2. And since we have a c, it would be 1, because it's c by itself. And -1. So this is our matrix. So now, from here, what our next goal to do, we'll have 1s running diagonally and having 0s fill up the remaining spots. And what we call this is the reduced row echelon form. I talked about this in the last video. So basically what that is what I said earlier. We have 1s running diagonally and 0s filling up the rest of the remaining slots. And in the end, this will be our answer, which we can replace with A, B, and C. So right now, this is our start. So that's our goal, to get the 0s in the remaining slots. So we have 0s up here, and what we need to do is get 0s here. So that's our next goal. Okay, so I moved to a new separate sheet of paper, a new blank paper, and right now this is what we made with our matrix. So right here we have a pivot, which is what we call this spot right here. It has to be a 1 because this is our start. So this has to be a 1. Since it's already 1, we're good. And our first step to making, so what we want to do in the reduced row echelon form, it's a lot better to start making 0s underneath, and we go this way. So since we start with 1, we'll get this to a 0, this to a 0, and then we'll move on like that. So downwards, and it's left to right. So because if we go this way, if we start here then go solve for this one, we might have to be changing it later when we try to go down here. So it's just a lot easier to go this way. So left to right, but it's going down first. So our first step is, let me rewrite it. So this is our original. I'll rewrite it right here. So our next step is to, so this basically represents what we're doing to the matrix. So what we can do here is we see that these are the same. So since we're trying to make a 0 here, we can turn this negative and add it to row 2. So we'll write that here, minus R3, which is basically saying negative R3 plus R2. R2 is back here because this is what we're solving for. So we're going to write this out. So what this looks like, I'll write it down here. It is -4 minus 2 minus 1. So this is basically negative row 3. So this is row 3 right here. This is row 3 and -1. Actually positive 1 because it's negative originally. So since we multiplied it by -1, it'll be positive now. So now we're going to add it to row 2. Row 2. This is row 2. So 4, 1, 0, and then -5. So now we have to add it. So what this looks like: 0, -1, -1, -4. So now, since we're solving for row 2, this is our new row 2. And row 3 will still stay the same. So now we're just going to have to rewrite it. So the top stays the same, row 1 stays the same. And row 2 is right here. This is our new row 2. So this is what we write up here now. So 0, -1, -1, -4. And then row 3 stays the same. So as you can tell, we got this as 0, but our pivots along the diagonal, you can see this is -1, which is okay, because like I said, we don't want to change this right now. We want to go down first. So we'll change this to a 0, and then we can worry about this. So don't worry about that, we'll get to it later. So now our next step, now that we have this, our next step is to get this 4 right here to be a 0. So to do that, we will multiply row 1 by -4, and we'll add row 3, so this will become a 0. So we can do that. So I'll write that out here. So we will be doing -4r1 plus r3. So what this looks like, it'll look like this: -4, 0, 0. This is row 1 times -4, and it'll be +8, and then we'll be adding to row 3. So row 3 is 4, 2, 1, -1. So now we're going to add it. Okay, so 7, 1, 2, 0. And this will be our new row 3, because that's what we were solving for, row 3. So now I'll write this into our new matrix. So this arrow is what we were doing. So it was -4, row 1 plus row 3. We'll draw out the matrix again. So row 1 stays the same, row 2 stays the same, and since we changed row 3, this is what our new row 3 will be. And 7. Okay, so this is what we have so far. So basically this row 3 went here. Okay, and so this is where we are right now. So our next step, we're almost done. Well, kind of. So now we have to get this to be a +1. Since this is already a 0, we have to get this a +1. And now, so to do that, we will multiply row 3. Actually, we can just use normal row 3 and add it to row 2. So that's what we'll do. Right here, row 3 plus row 2 to our matrix. And so row 3 will look like this: 0, 2, 1, -7. And row 2, 0, -1, -1, -4. We will be adding them. So this looks like 3, 0, +1, which is what we wanted, and 0. So this is a perfect replacement for row 2. So row 1 stays the same because you haven't changed row 1, -2, because we know a equals -2 from what we found before. So this is what we have here, and we're replacing row 2. So this will be right here. So 0, 1, 0, 3, and row 3 stayed the same. So 0, 2, 1, 7. So as you can see, our row echelon form is almost finished. We just need this 2 to be a 0, and we will have our answer, our final answer here. So the last step is to multiply row 2. So we can see row 2, right? To get this to be a 0, we can multiply it right here. We can multiply it by -2. So row 2 by -2, and we'll add row 3. So that'll make this, it'll add to 0. So that's what I'm gonna write right here, being -2 R2 plus R3. So I'll write that out here. So row 2, negative row 2, no, negative 2 times row 2 here, and then negative 6 and plus row 3. So it's just normal row 3. It will be 0, 2, 1, and 7. So now we will add this up. We get 1 here for our answer. 1, 0, 0. So this right here will replace our row 3. So the final matrix will look like this: 2, 3, 0, 1, 0, 0, 0, 1. From what we got here, 1, 0. So now with the row echelon form complete, we have our final answer right here. And what this looks like, so what we want to do, we want to go back to what we had last time, right here, seeing how we used A, B, and C. So what we do is replace it with our final answer that we got earlier. We replace it here. So what that looks like, it'll look like this: 2x squared. This is the original problem. Negative 2x squared minus 5x minus 1 over x plus 2 cubed. And then this equals, so what we had originally was x plus 2 plus x plus 2 squared plus x plus 2 cubed, right? And then we would have a, b, and c, but now we can replace a, b, and c with this, like this. So negative 2 is a, so we're right here, negative 2. 3 was b, and what we got for c is 1. So this whole thing here is the decomposed fraction. So this whole thing is our final answer.